Shubhasiri. And yesterday's session, I was completely mesmerized. I learned so many things, not only DA and other economic theories, but also how to teach. That is magical. Some more magic is left. But before that, we want to welcome properly Professor Ray. So I request Sneha to do the needful. Sneha, please.
Yes, ma'am. Wishing a very good evening. I would like to extend a hearty welcome to one and all present here for the second session of today's FDP program.
Can you turn your video on, please?
Yes, sorry, I forgot to turn my video on. Yeah. Okay, so I would like to give a warm welcome and a hearty welcome to one and all present here for the second session of today's FDP program. To start with, I would like to dedicate this session to a Bengali polymath who worked as a poet, writer, composer, philosopher, and also a social reformer who is none other than Rabindranath Tagore. Born on 7th May 1861 in Calcutta as the youngest son of Debendranath Tagore and Sharda Devi, he became a man of prodigious literary and artistic accomplishments and played a leading role in the Indian cultural and national movements. Rabindranath Tagore became the first Asian to win the Nobel Prize in 1913 for his collection of poems Gitanjali. He is called Gurudev, Kavi Guru, and Vishwakavi affectionately, and his songs are popularly known as Rabindra Sangeet. In the year 1921, Rabindranath Tagore established Vishwabharati University and gave all his money from Nobel Prize and royalty money from his books to this university. Tagore was quite knowledgeable of Western culture, especially Western poetry and sciences. He had a good grasp of modern post-Newtonian physics and was well able to hold his own in a debate with Einstein in 1930 on the newly emerging principles of quantum mechanics, contemporaries and chaos. His meetings and tape-recorded conversations with his contemporaries such as Albert Einstein and H.G. Wells epitomize his brilliance. In 1940, Oxford University arranged a special ceremony in Shantiniketan and awarded Rabindranath Tagore with a doctorate of literature. He is an iconic figure in the Indian cultural renaissance. Tagore believed that the main objective of teaching is not to give explanations, but to knock on the doors of the mind. Rabindranath Tagore or Gurudev is considered one of the best teachers in Indian history and is still remembered for his scholastic excellence. Here, I would like to highlight one of his famous quotes on education, which states that the highest education is that which does not merely give us information, but makes our lives in harmony with all excellence. With these few words, we would like to start the second session of online 2-week faculty development program on research methodology and applied econometrics for social sciences organized by Department of Business Administration, Assam University, Silchar, in collaboration with Vidyasagar University. And for this session, we are privileged and honored to have Professor Subhash C. Rai sir with us once again. Sir is already introduced to us yesterday in yesterday's session. So I would just say that Professor Subhash C. Rai sir is a professor of economics at the University of Connecticut, USA. And his principal area of research is non-parametric measurement of productivity and efficiency using data envelopment analysis or DEA. And in today's session, he will be enlightening us with constant returns to scale, separating technical and scale efficiencies, and also non-radical measures of Pareto-Koopman's efficiency. With this, I would like to hand over this session to you, sir. Thank you, sir.
Okay, can you folks hear me?
Yes,
Yes, sir.
Okay, now that mutual praise is over, let's get down to business. Now, before that, I just want to remind you that today is Teachers' Day in China. And also there was a Teachers' Day lately in India. In the US, we do not have any Teachers' Day. And So if you're wishing a happy Teacher's Day to your English teacher, make sure that you spell it correct, because the teacher will ask you to write teacher incorrect spelling for 100 times, even though you have passed out. Okay, so let's get down to where we were last time. Let me just open my files. Well, how do I go back to the Zoom? How do I go back to the Zoom screen?
So if you move your cursor the top of the screen, you will have the response from there.
Because I don't see the Zoom in the lower taskbar.
It's at the top.
And at the top, I just see the okay. Do I click on this the video icon?
Sir, if you need to share, then you can put on share screen, sir. Is there share screen button at the bottom?
No, but what I have here is just the blank.
But we can see you and the screen, sir.
Yeah, you can see me, but I am trying to get back there. I always get confused with this. I usually work on WebEx.
Sir, can you please press escape and find whether you are on full screen or not?
Say
Just
that?
click escape. Just click escape. ESC in keyboard you will find ESC. You just click that one.
Which button?
ESC, escape.
Yeah, escape I can do, yes, but it didn't take me out of this thing. Do you see my screen?
No, sir, it's not shared yet.
I had this problem before and yesterday, and I wasted so much time on this thing. But when I do share it, it takes me to something else. That is a Microsoft OneDrive.
So if you can share the material with us, we can share it from our end. Will it be okay?
What's that?
If you share the material with us, we can share it from our end.
No, I don't, because the thing is I want control and I want to go back and forth. So if I do, then it kind of commits me to restrict myself to whatever I have sent you. And that's not what I want. I want to, now it should be. I see the share screen, but I do not see the stuff that can you see it
Started, sir.
now?
It started. Yeah, fine.
Okay, thank you. This is where we left last time. So let me tell you what my plan is for today. First, I will slowly go over this example and show you how you can compute the efficiency of each of these 5 units without having to edit every time. Because as you can see, let us focus on this LP. Notice that in this LP, as I evaluate the efficiency of any unit, the constraints on the left-hand side, the constraint on the left-hand side is, this is a weighted average of the actual outputs. This is a weighted average of the labor quantities. This is the weighted average of the capital quantities. And this is the restriction that the weights add up to 100%. And of course, the weights are non-negative. What changes, the left-hand side does not change as you evaluate unit 1, unit 2, unit 3, etc. Because what is happening is this. What is happening is that we are creating some weighted average. And when I'm going to unit number 2, unit number 3, I am creating another weighted average. But the thing is, so between unit number 1 and unit number 2, when I'm actually solving this, the weights are changing. As I solve, the weights are changing. But the restrictions on the left-hand side in algebraic form do not change. Only the optimal values of lambda 1, lambda a through lambda e, these are changing when you are evaluating A or B or C or D or E. What is changing is that when you are evaluating A, you would enter the actual output and the actual inputs of A on the right-hand side. Here, for example, this is for C. So here we have the actual output of C and the 2 inputs of C. When we go to D, we simply will replace this by 13, which is the output of D, and 7 and 6. Now, if I have got a large number of observations, that's a lot of work to do. So what I want the computer or Excel to do is to say that, look, as I compute, I will give you the unit number. And what you will do is that you will pick up the actual output and the actual inputs of the appropriate unit number and put them on the right-hand side and then solve it. And then I will change the unit number and you will then bring the actual input and output of the next unit as I have changed the unit number and solve it. So how do I do that? Well, let me first create my column of lambdas. So these are my lambdas, and remember that it is a good idea to identify them, that these are going to be your choice variables. And then I am going to have a new cell where I am entering the unit number 1. And then I copy these are my left-hand side. these are my right hand side. And let us say that I also want to, when I compare the target output input bundle, I want to compare it with the actual to see how much the output is increasing, how much any input is declining. So I include a row called actual. Okay, first I want to enter the actual values of the output and input of unit number 1. So what I will do is that I will write here is equal to index, open parenthesis, and then drag over the y column, comma, and then go to the unit number and hit an F4. When you hit that F4, then that becomes a fixed cell and close it. Oh, obviously, that's not true. It did something else. Okay, actual equal to index of the y column, comma, the unit cell, hit F4 and close. So now you see that it has picked up in the y column, I dragged over the rows 2 through 6. And here I am saying that in this array, pick up the element number which is identified by the unit. So it picked up the first element. And now I just copy this formula across. So these are my actual. These are my actual. Now you might ask, why did I have to hit F4? Because here I am saying you look at so this is equal to the index in the array C2 through C6, the element number which is identified in the cell G2. And the number element, the number identified in G2 is 1. So it picked up the first element. Now, if I did not hit F4, then what this would do is that it would go to H2. But H2 is not a number. So what I'm saying is that now go to the next column and in the same rows, the same array of rows, pick up the element which is the element number shown in G2. And that's why I hit the F4. Similarly, okay, let me also introduce a cell for phi. And remember, this is also one of my choice variables, but it is also my objective function cell. So I color it in a special color. And now, first, let us create the left-hand sides. The left-hand sides are the sum product of the lambda column is the sum product of the lambda column is equal to the sum product of the lambda column. And you hit an F4 here, comma, the output column. Again, why did I hit an F4? Because the second left-hand side, the left-hand side for the labor constraint, is also a sum product of the same lambda column, but this times with the labor column. So if I copy this across, you will see that if you look at the formula bar, that now the second array changed from C2 to D2. I'm sorry, C2 to C6, it became D2 to D6, and it became E2 to E6, but the first array didn't change. The first array is F2 to F6, which is fixed. So I have got the left-hand side. What is the right-hand side? The right-hand sides are, of course, the actual output of the unit being evaluated multiplied by phi and the actual inputs of the units. So what I will do is first, I will just write this is equal to this and then copy this. But this is not the correct right-hand side. It is the correct right-hand side for the labor and the capital constraints, but it is not for the output constraint. The output constraint, as you can see, the output constraint is 10 times phi, or I mean 15 times phi. So I modify this, only this is equal to this times this. Now we are all set except for the the sum of the weights constraints. So I put sum as this, and this is equal to the sum of the lambdas. That would be the left-hand side of my sum constraints. Now notice that if I wanted to do the same thing for C, which you have got here, all I needed to do is change the unit number to 3. Because the left-hand side didn't change at all, and the right-hand side, now you have got the actual input outputs of C, and here you have got the actual output of C multiplied by phi, and the actual inputs of C and labor and capital of C. So I do not have to enter it every time. This index function is extremely useful. So let us look at this. So let me also have this as efficiency, and this is equal to 1 over phi. Of course, initially it is 0, don't worry about it. Go to data. Let me start with 1. Okay, let me start with 1. Maybe what you might want to do is that, well, actually you have the unit number, so you don't have to do anything, but you would want to record what is the efficiency of unit 1, unit 2, unit 3 as you solve each one of them. So let's go to data and solver. And notice that right now it is saying that my objective function cell is G3. Why? Because I casually left my cursor on column G, row 3. But that, of course, is not my objective function. That's just text. So that's why I colored the objective function cell in green, so that I don't have to look around. I just click on this one, and that's my objective function. It's a maximization problem. So, and then the changing variable cells are this one, the phi, not the letter phi, is the cell where the value of phi will appear. And Then you have a comma, and then you drag over the, again you see why I colored the column lambda in yellow or any color, because then I don't have to worry about, did I miss some cell? Did I include some unnecessary cells? All I need to do is just drag over the, it's my reminder. It's wearing a badge that this is a column of my choice variables. Then you add the constraints. The constraints are the left-hand side of output is greater than or equal to the right-hand side of the output. And then you also add the two left-hand sides of the inputs are less than or equal to the two right-hand sides of the inputs, and also add that the sum of the lambdas is equal to 1. And once you have finished entering, you hit OK. So this shows that I have got this constraint G6 equal to 1. What is G6? G6 is the sum of the lambdas. Then I2 is greater than equal to I3. I2 is the left-hand side of output. I3 is the right-hand side of the output. And then J and K2 are less than or equal to corresponding J and K of 3. So all of my constraints are taken care of. Non-negativity is imposed, and change it to simplex LP and solve it. So this says that the efficiency of unit 1 is 1. There is no other weighted average or convex combination of the outputs and inputs which will produce more output from no more input of labor and capital than one is producing. Let's do it for 2. Two is also efficient. Don't worry about this. This is actually, sometimes the computer, this actually is showing that there are, after decimal, there are 17 zeros, after which you have got any significant digit. So that is 0. This actually is 1. Okay, so if you feel uncomfortable about it, you can do a format cell. Okay, you can do a format cell and make them whole numbers, but don't worry about it. You will, this E minus 17 means that this is 5.55 multiplied by 10 to the power of minus 17. So you have got 16 zeros before you have got this 5, etc. That is 0. So actually this is equal to 1. And that's what is showing here, that phi is equal to 1 and the efficiency is 1. Unit number 3. Solver, solve. This time you see that the unit number 3 is not efficient. This is your actual, and this is the left-hand side is the weighted average input-output bundle that you are going to create. So that's your target input-output bundle. And from there, you can see the LHS row with the actual row to see that C is producing 10 units of the output, should be able to produce 14.57 and so on units of the output. C is using 8 units of labor, should be able to produce this new output, higher output, with even less labor. So there will be even leftover labor, 4.142628 instead of 8. And your capital would be fully utilized. So the efficiency, what are the two important things that we learn here? One is how much the new output will be, and what is the actual output as a proportion of this new output, and that is your efficiency. And this is the expansion factor. And similarly, you can go on doing this. As a matter of fact, you might want to record the names also. So every time it's not, because unit number 1, 2, 3, 4, etc. is for calculation, but sometimes you want to know what are the names of the units that I'm talking about. So this name is equal to index. And this time I drag over the name column, comma, and then this unit. This time I don't need to hit an F4 because I am not copying this formula anywhere. So you know that this is unit number 3. It is the firm C, and this is what it is producing from the inputs that it is using. This is what it should be able to produce, and this would be the associated inputs that would be needed to produce the output. And notice that the required labor is no more than, and actually is strictly less than, the actual labor that she is using. Required capital is exactly equal to, but no more than. So that there you are saying that C should be able to produce 14.57143 units of the output rather than 10, requiring no more than the labor capital bundle of 88 that it is using now. I am not penalizing C for not using all of its labor. I'm simply saying, so it's almost like, let's say that you are a family farm and you are using family labor. So we were asking, I have got this much land and this much labor, and this is output I am producing. And what is the maximum output that I can produce without hiring any labor, remaining within my family labor, and without requiring any additional land. But if I do not need all the family labor, that's okay. They're going to eat their 2 servings of rice at home anyway. So I cannot kick them out. So I am more interested in producing the maximum output. This is output-oriented efficiency. Now here is a problem. Now that you have figured out that I can do this without actually having to enter all the information on the right hand side every time I do it, is there some way I can do all of this without going one after the other after the other? In other words, you want to know, is it possible to do all of them by running a single program rather than doing it every time? You see, the thing is, many years back, I had a friend. He spent some time in what then was called Madras. And so I asked him, did you learn any Tamil? And he said, yes, some. And I asked him, what do you say in Tamil if you have to ask, come here? And he said, Ingava. And then I asked him, what do you say when you go there? And he scratched his head and he said, I go there and say Ingeba. So is there some way I can have to do that, get the person to go there without myself going there again? So here I want to solve this problem. I want to solve this problem without having to run every time. I want to run only once. And that is the macro. Okay, that is the macro. Now, in order to write the macro, I am going to give you the instruction. Actually, the child's guide paper that I sent you, if you read it, I hope that you will read it. Anybody who is seriously interested in doing DA should read that. It really is a child's guide in the sense, of course, not a child in the sense of a 3-year-old kid, but a child's guide in the sense that even a simple beginner can understand it. If you will find that there is an example of a VBA macro that is explained in detail. Actually, that part was written by my then graduate student, Lei Chen, and he did a very good job of explaining the stuff. So now I want to create a, because even if I did this, I will have to write down what is the name of the firm, what is the efficiency before I go to the next one, because everything is replaced. I do not have anything on record. Well, before that, let's do this. You will see that in the ribbon, there is something called developer. Do you see the developer in your ribbon? Do you see the developer in your ribbon? Can somebody tell me whether you see the developer in your ribbon? Can somebody tell me whether you see the developer in your ribbon? Well, it doesn't look like, okay, let me see what. Yes, in Excel, of course, in Excel. Now, for those of you who do not see the developer in the ribbon, I'm going to show you. If you do not see the developer in your ribbon, you should go to File, go to Options, and then go to Customize Ribbon. And in the Customize Ribbon, you will see that these are the stuff that you want to show in the top ribbon, and this developer should be checked. If you check the developer, it will be there. Okay, and I'm going to close it. So go to developer and click. Once you go to developer and click, you will find something called insert, and click on insert. When you click on insert, you get two sets of icons. The top are form controls and the lower are ActiveX control. So click on ActiveX control. Now you will see that my cursor has become a cross. And you bring it somewhere where you can keep it. So let's say that I bring it here. And now you see that you are getting a command button, and this is supported by these circles. You bring your cursor here, which is now a plus sign, and click. Now you are getting an editor. Now you have got in this editor, the VBA macro editor, you have got the private sub, etc., and end sub. Don't ask me what do they mean. I don't care. So long as it does my job, I'm happy with it. So here you write for unit equals 1 to 5. So I want to run this macro. for 5 units, starting from unit number 1, going to unit number 5. Then you need to tell, so you go to the next line, you need to tell what your unit number is. So if you go, notice that now I am in the editor window, but my original Excel is also open. So here I see that my unit, make a note of this thing. You find that your unit is in G2. And so you go back to the editor. Here you have to be very careful with the punctuation. Range, open parenthesis, open double quotes, G2, close double quotes, close parenthesis, equals unit. So you are basically telling the macro that the unit is in cell G2. And then you write solver solve user finish colon equal true. Now this actually is their code. I don't understand it, but it basically says that I do not want to see the iterative steps. I want to see the final result. Okay. And then you write next unit. So your VBA macro is complete. Next, you go to tools. In the tools menu, go to reference. And in this reference, there are a whole bunch of programs, and you click on the solver. Okay, and now you are ready. So you can minimize this. Now you see that you are still in the editor mode. How do I know? Because the command button is still supported by the circles, and your this thing is still a plus. Now you click on the design mode, and now you are out of the design mode. You are ready to run the program. Now notice that right now I have got unit number 3. It doesn't care. It will, because I have ordered it to do unit 1 through 5, it will start with unit 1. Okay, so, and you just click on this thing. You see, it has actually done all of those. But this is of little comfort to you. Why? Because even before you could blink, it moved to the next unit and did it, so you had no time to copy anything. Because what it is doing is that it is running a program, then wiping it clean, and then starting for the next one. So you want to record them. So you want the computer to record whatever information you want into a particular table, which you can then export to a paper or wherever you want to do an Excel table. Okay. So what I want is this. I want to record the following. I want to have unit name, and then let me move this a little bit. fee and efficiency. So basically what I want is that I want a table here with 5 rows, which will record unit number 1, 2, 3, 4, 5. The names will be A, B, C, D, E. The fees will be what are the optimal values of fee, and then the efficiencies will be the corresponding values of efficiency. These are what I want. So essentially what you want to do, you see, for each unit that you have, you are running, the unit number is given here, the name is given here, the fee is given here, and the efficiency is given here. So what you want is start with unit number 1, solve it, and then copy the unit number, the name, the fee, and the efficiency for the unit that you did, and then go to the next row in this table and do it for unit 2, do it for unit 3, and so on. So for that, what you need to do is this. You record what is in your LP that you are running and what do you want to keep. So essentially what you want is this, that you want to record the following. You want G2 should go to L2 and name is G8. G8 should go to M2. And then what you have, your fee is G4. G4 should go to N2 and the efficiency is H6. H6 should go to O2. Now here is the problem. If you want to do that, let's do that, and then I'm going to show what the problem is and how to correct it. Okay. So let's go to the solver, rather the editor. And before you go to the next unit, so essentially you are telling, please do it for unit number 1 through unit number 5. The unit number 5 is the unit number is in column G, row 2. And then the next line is to ask the solver to solve the problem. And before it goes to the next unit, you want to record these 4 values from the cells G2, G8, G4, H6 into L2, M2, N2, and O2. So what you do is range L2, again, range, open parenthesis, double quotes, L2, close, equal to range, open parenthesis, open quotes, G2, and then range, open parenthesis, G8, close quote, close parenthesis, equal to range, M2, range, G4, equal to range, N2, and See, it is very particular. It doesn't want any kind of a lack of space or here. And finally, if you, oh, I missed, you see, I missed this open quote here on G4. That's why it is reminding me all the time. And finally, range H6 equals range O2. And then you go to next unit, not this one. Before you go to next unit, why did it not record this? What was the problem? Let me check one more time. Solver solve, user finish, range L2, LG2. Actually, this should be the left-hand side would be the target cells where you are moving. The right-hand side would be the source. So this should be the M2, L2, LMN, and O2. This is, and these are G8. I'm sorry about this. G8, G4, and H6. So on the left-hand side is where you want to record the values. And on the right-hand side are the values that you have after you solve. Why do I not have the name? So you see, after all this work and also all these errors, I ended up with the information only about the last one. And that's not what I want. What it is doing is that it is starting with 1 and recording, and then going to 2 and is overwriting. So I do not want to start that this is the unit number 1, this is the name A, this is the efficiency, this is the fee, this is the efficiency. And then on the same row, I write this is number 2, this is B, etc., etc. I want it to go down so that it records. So after it does all of this, I want to go to the next row and keep the old row. To do that, what I need to do is I go to the VBA. So my starting is L2 and M2 and N2 and O2. But then I want to go to L3 and M3 and so on and so forth. So essentially, what is this 2 or 3? These are actually the row that corresponds to the unit number plus 1, right? Because we have a title row. We have a title row. Here, I am starting with row number 2 in LMNO. That is row number unit plus 1. Now, when I go to unit 2, that will become row number 3. So that would be row number unit plus 1, because 2 is now the unit. So essentially what I do here is this. I edit this as range L within quotes, put a space, and the ampersand, and unit plus 1. Similarly, M, not M2, just M, column, that's the column is M, and the row is and unit plus 1. N and unit plus 1. And O and unit plus 1. Okay, now we are done. Let's go there and start. So we have got all the results that we need, A, B, C, D, and E. These are the names. The unit numbers are 1, 2, 3, 4, 5. The corresponding fee values are 1, 1, and then 1.45, 1.05, 1.045, and so on. And the corresponding efficiencies are 100%, 100%, 68.6%, 94.7%, 8%, 68.6%, and so on. Okay, let me pause here, and then I will go to a bigger problem. And let me ask you if you have got any questions. Do you have any questions?
Dr. Lolita PS, you have question you have written on the chat box. Please ask. Are you there? Dr. Lolita PS?
Well, perhaps she is not able to listen. Maybe uh, her audio is probably not working. Anybody else have any question? Well, if you don't, then let me go back and let us now go to something which is big. Okay. Yeah, I couldn't hear you.
If you have question, please ask.
Well, how do I get back to the full screen? How do I get back to the full screen?
Sir, just kindly click on your PPT. So Excel file. Can you click on your Excel file?
I cannot hear what you are saying. I mean,
So kindly click on your Excel file. You want to just move in Excel file, no, sir. So just click on your Excel file.
there's the Excel file itself.
Yes. Sir.
Okay.
Yeah. This one, sir. Please click. Yes, sir. Visible, sir. Please go ahead.
Okay, here is the state electricity board data, and let's work on this thing here. I have got this is an old data. In fact, I used this at a workshop long time back in NTPC, showing them how you can analyze the performance of the state electricity boards. So here I have got the data from 26 SEBs from the different states of India for the year 2001. And my outputs are supply in megawatt hours, and then the establishment expenditure, which is a measure of the total expenditure on labor. And then we have got power and fuel expenditure, and we have got capital. And so I want to find out for each of these states from the inputs that they are using. And of course, you will be much more careful in defining your inputs rather than casually measuring input by cost, because the price differences might reflect differences without they actually showing differences in quantities. But just for illustration, let's say that these are the outputs and inputs. And so let me just call them labor and fuel and capital. And this is my output, and I want to do this for each of the SUVs. Now, it might be a good idea when you are doing something like this to, to actually create a new column. So you insert a column, and so these are my 26 units. And I want to do the output-oriented measure of efficiency for each of these units and record them in a table like the way we did before. So again, what I do is that I have here, let's say, it doesn't matter where you are writing, unit, and let's say that that's my unit number 1. And then I have got my lambda. I don't want to waste time on that. So these are my lambdas. You can call whatever you like. And so these are my lambdas. And then I have got my left-hand side. The right-hand side, the actual, and so these are my output and inputs. I start with, first of all, as I did before, I start with the, okay. I start with the actuals, and so that would be equal to index. I drag over the output column, comma, the unit and F4 and close. And copy them. So these are my actual quantities. Now my left-hand side is the sum product of the lambdas and the output column, which is the supply, and then the 3 input columns. So this will be equal to the sum product equal to the sum product of the lambdas. So you see the advantage of coloring. I don't have to worry about, am I going too much, too little, hit F4, comma. This time drag over the supply or the output. And close. And then you copy this formula across. So these are the the left hand sides, and the right hand sides, as you see, this is equal to this, and then I copy across, and then I create a fee, and this is equal to this times phi. I've got the left hand and the right hand sides already. And then I go to sum, or rather let me have the efficiency here, or whatever. Efficiency that is equal to 1 over the phi, and then I have got sum, which is equal to the sum of the yellow cells. And now we are all ready. We go to data and solver. Before we do that, let me also have the name, because that is important. I want to know what is the name of the SUV. So that is equal to index, and you drag over the, oh no, not here. Next column, next row. Equal to index, and you drag over the name column, comma, and close. So you have got the name and you have got the program all set up. Go to data and go to solver. Your objective function cell is this one. It is a maximization problem. Let me get, there was an old problem here. So this is my, I'm starting from scratch. My objective function is this one. This is a max problem, and the changing variable cells are phi, comma, the lambdas, and the constraints are the left hand side is greater than or equal to the right hand side for the output, and add the left hand sides of the inputs are less than or equal to the right hand sides of the inputs, which means that the target unit that I am creating should not be using any input more than what this input is actually using now. And then you add that the sum is equal to 1. Change this to simplex LP. Let me, actually, when you have got many Excels open, you get into a problem. So let me first close the earlier Excel, okay? Too many Excels open often create a problem. So the efficiency of Andhra is 1. Again, you notice that there are some entries here, but these are 16 places of 16 zeros after the first decimal. That's also 0. Now, if I go to 2, now this is a sum. Efficiency of Assam is very low, is 0.47. And it tells me that Assam is producing 16 megawatt, 1000 megawatts or whatever of power. It should be able to produce 43. And it is actually using, its labor is fully utilized, its fuel is fully utilized, but it has got a considerable amount of unutilized capital. Its actual capital is 406,192. The required capital is 301,668. So you are able to do this for each one of them. And so let me just do the VBA macro on this thing. And then I will show you how you would do this if you were asking a different question. You were asking that I am not interested in producing more power. I want to know what is the reduction in inputs that I can achieve without reducing output. That is the input-oriented efficiency. But let me do this for all the units through the VBA, so that will give you another practice of the VBA. So what do we want to record? We want to record unit, then fee, then efficiency, then name. So where are they and what do we want to take them? Unit is in G2 and want to take that to N2. The name, or rather the fee, is in G4. I want to take it to O2. The efficiency is in N6, in H6. I want to take it to P2, and name is in G10, is in H10, and I want to take it to Q2. So I create again, I go to developer, insert, ActiveX control the first box. For unit equals 1 to 26. Range G2 equals unit. That's very important. You have to tell the computer where exactly is your unit number cell is. Then solve, user finish, colon equal true. Notice that whichever way I write it, it has its own syntax. I use solve with uppercase S, and everything else I true, etc. I wrote in user finish, I wrote in uppercase true, but it actually created, so it changed the lowercase t into uppercase T in true. Now, before I go to the next unit, I want to record all this. So what do I want? I want the information in G2 to go to column N and unit number what? Unit number, notice that this is row number. Actually, if I had written the title here, that would be row number 3. So the starting row is the unit plus the number of rows before that. So this is the starting row is unit plus 1. So this will be range N, open and close quote, and unit plus 1 equals range G2. And what I will do is, to save time, is that I will just copy it for 3 more times and change the information. O P and Q. So these are my target cells, Q, and these are going from G2, G4, G2, G4, H6, and H10. And then you enter next unit. Again, when you are starting, you have to go to Tools, Reference, click on Solver, OK. and close the VBA window, and you are still in the edit mode. So you click on the design mode, and now you are in the execute mode. So now you come and go there. What's the problem? Oh, well, actually, once you make an error, it often doesn't want to run it. So the best thing is, if you make an error, first save this, okay? So file, save as, and then I save it in one of my these things. And the important thing is that you should save this as a macro, because otherwise your macro will be gone. So do not save this as an Excel workbook. Save this as Excel macro enabled workbook, because now it will be saved as an Excel AM. Okay, and let me close this now and open this again. Why is it writing the only the same thing? What did I make the error? Let me open the VBA. G2 equal to unit, that is correct. Solver O2 MNOPQ. Maybe I gave it the, oh, these are not G at all. This is G2, but fee is H and efficiency is H. And these are all H. That's what the problem was. I gave the wrong source. So this is H. So this is H4. Phi is H4, and then efficiency is H6, and name is H10. H4, H6, H10. Okay, I think that should work. What did I miss again? Any idea? Then G2 is equal to unit is correct.
Participants are answering in the chat box, sir.
Where is this 2 come from? Where did this 2 come from? Any idea? This is the index. That is correct. And then efficiency is here, and that is, so index is, unit is G2, and efficiency is, fee is H4, and efficiency is H6. And why are the names coming here? Let me get out of this thing and do it again, okay? I'm sorry about this thing. Because I have a little bit of difficulty working on this small screen. I have got too many things open. This is G3, not G2. Unit is G3, and then fee is H4, and efficiency is H6, and name is H10. So let me go back to the, G3 is unit, and then this is N is G3. G3, G4, H6, H10. It is getting the efficiency column right, but why is it not writing? O2 is actually, O2 is not G4, O2 is H4. But I have got O2. O2 is H4. Okay, so here you have got, I'm sorry about this, that's why it is, why is this 26 is 0? Why is 26 0?
But HSC is a hash dividend.
Which one?
HSC.
Somehow the other numbers look correct, but the 26 is 0, it shouldn't be. It somehow
Maybe the same value what it is in HSC was supplied in.
your voice is getting distorted. I really cannot hear.
Sir, in actual output, the hello, sir.
Yes.
Sir, in actual output, you didn't select the S30. Tripura. Tripura is not included.
It's not. Why is not?
Sir, when you selected in the column.
Oh, I stopped at 26.
Yes, sir. Yes. 27,
yes.
5, sir.
Yeah, it should be 5 to 30, right?
Yes, sir. Yes, sir.
Yeah, okay. So these are the, I'm sorry about the problems we had with this thing, but if you read the child's guide and also go through this thing, you should be able to figure out. And I hope that now you realize why I did not recommend any software, because in some cases, say for example, you are interested in only knowing what is the minimum amount of fuel that I need to use. You are interested in energy use efficiency in power generation. And you wanted to know, I do not want to increase output. I will try to simply cut down on my fuel without increasing labor and without increasing capital. So just I want to cut down on fuel. In that case, the model would look like something like this. Well, first of all, let me talk generally about input-oriented model, and then I will talk about a specific input-oriented model. So, no, this is an output-oriented model. Here, what you are trying to do is this, that you have got M outputs and N inputs, X1, X2, X3, etc., Xn. And you want to find out by what factor I can cut down all of the inputs by the same proportion, because when you don't have any prices, you don't know which input is more important and which input is less important. Then you would say that I will take the input bundle and I ask, can I produce this output with 10% less of all inputs? Can I produce this output with 15% less of all inputs? Now, depending upon your actual data, it is possible that you will be able to produce the same output with 15% less of labor and only 12% less of capital. In which case you say that the maximum reduction that is possible across all inputs is 12%. Although I can cut labor by another 3%, I cannot cut capital by any more. So that is essentially by what proportion you can cut down all of your inputs without making the output bundle that you are producing infeasible. So what you are doing is, again, you are creating for each input I a weighted average or a convex combination of the observed input of I. Let's say that I is equal to 1 and 2, input 1 and input 2. Then you want to know what is the minimum value of theta. What is the minimum value of theta such that the sum of lambda j x1j is less than equal to theta times x10, and the sum of lambda j x2j is less than equal to theta times x20. So say x10 is the actual quantity of labor. X20 is the actual quantity of capital. And you are creating, let's say, some input bundle X bar, which is X1 bar, X2 bar, where X1 bar is the weighted average of the actual labor of everybody, and X2 bar is the weighted average of actual capital of everybody. And correspondingly, you are creating the weighted average output, and you want to select your weights such that the weighted average of the outputs will be at least as large as the observed output of the farm you are evaluating. and the weighted average of the inputs would be no more than theta times the actual input of the farm that you are evaluating, and the weights have to be less than greater than equal to 0 and add up to 100%. And there what you are doing is that you are actually what you are doing is that you are trying to find out what is the smallest value of theta. That this, let's say that the weighted average, your actual input is 20 and 50. And your first input can be reduced to 15. But the second input can be reduced only to 40. You cannot cut it anymore. So that means that you can reduce your second input by a factor of 0.8, 20% reduction. Although your first input can be reduced by a factor of 0.75, 25% reduction. So there you are going to say that the minimum value of theta, that is the input reduction factor that can be applied all across, is 0.8. Because for labor, you can go to 0.75, but for capital, you cannot go down any further. So your efficiency in that case is just the value of theta by which you can scale down everything. This is the input-oriented measure of technical efficiency. Now, here I am talking about cutting down everything. But what if I am not interested in cutting down everything? Because the problem here is that suppose that there is some input which you cannot cut down at all. But there are other inputs which you can cut down by a lot. In that case, you would say that my efficiency is 100% because theta cannot be reduced by any factor for that critical input. So sometimes we want to do a targeted input reduction so that I am interested in conserving energy. I am interested in conserving energy without violating the output, having to reduce it, or without requiring any additional input, but I don't care if you do not cut down on the other inputs. My focus is exclusively on energy. So here, let us look at this problem. What is this coming up? Can somebody tell me where these lines are coming up? Is somebody else sharing my screen? Is somebody else sharing my screen? Is somebody else sharing my screen? Where are these lines coming up from?
So now it's fine, I think.
Is that the whiteboard that is coming up?
So nothing is coming up on the slide.
But I see, I have stopped sharing right now, actually.
Yeah, it's fine, so it's fine. So you just let me know so that you log in through the browser, no? Zoom browser.
Yeah, but I am not using
Yes,
any pen.
yeah. So Your screen is visible, sir. Now your screen is visible. Perfect, sir. Now your screen is visible, sir. Excel file can be, everyone can see in the Excel file.
Okay, here I'm using the same SUV data. Okay, I'm using the same SUV data, and these are the output, the labor, which is establishment expense, fuel, which is the expense on fuel and purchase power, capital. It consists of interest, depreciation, repair, and maintenance expenses. So that those are the not the value of the capital, but the cost, what is known as the user cost of capital. And I want to know if and how far can we reduce fuel expense of any SEB without reducing output and without increasing any other input. Okay. So these are the data that we had. And suppose arbitrarily I picked up the State Electricity Board of Rajasthan, and I say that, look, it is producing so many megawatt hours, 17686, and is spending so much on labor, this 635811, and this much on fuel, this much on fuel, and this much on capital expenses, that is operating capital expenses. And is it possible to cut down on fuel without generating less power than it is producing now, without increasing its expenses on labor, without increasing its expenses on capital? So this is the model. Notice that these are the actual output, the actual labor, the actual capital, and the actual fuel of Rajasthan. And these are the weighted average or convex combination of the observed values, that is the sum product of the lambdas and the output column, that is the sum product of the lambdas and the output column for the data set. So this is the weighted average output. These are the weighted average labor, weighted average capital, weighted average fuel, and the weights add up to 100%. I want to select the weights such that the corresponding weighted average output will be no lower than the actual power supply of Rajasthan. The corresponding weighted average of labor will be no more than, so I don't require any more labor than Rajasthan. I don't require any more capital than Rajasthan. And the weighted average of fuel will be no more than theta times the actual fuel of Rajasthan. As I told you before, that one possibility is select lambda Rajasthan equal to 1 and everything else equal to 0. In that case, the weighted average is equal to the actual and theta is equal to 1. So theta is equal to 1 is always possible. Theta equal to 1 means that just leave it as it is and you can produce the actual output from the actual input, which is always the case. The question is, can I select some other combination of the lambdas which will give me a reduction in fuel without any reduction in output and without any increase in labor capital, and the weights have to add up to 100%. So this is an input-oriented model, but I am not trying to find out by what factor I can cut down labor, capital, and fuel, everything by that percent. I am simply saying that fuel is my priority input, and I want to minimize the use of fuel by scaling it down without increasing either labor or capital, and without reducing the output. So when I solve this problem, I find that the weights are 0.44 for Pondicherry, 0.34 for Tamil Nadu, 0.30 for Andhra, and 0.02 for Punjab. These weights add up to 100%. These weights add up to 100%, and the weights given to the other ones. So here you see that I am applying these to, I have got all these outputs and inputs, and of them, I am applying the strictly positive weights to Pondicherry, Tamil Nadu, Andhra, and Punjab. So 44% of Pondicherry here, 44% of Pondicherry, and then Tamil Nadu, how much was Tamil Nadu? Tamil Nadu, 24% of Tamil Nadu, 30% of Andhra, and a very small percent, 2% of Punjab, will create an input-output bundle. So notice that I am ignoring everybody else. I am giving weight to only these four. But these weights add up to 100%. And as a result, what is the weighted average of output? What are the weighted average of the inputs? The weighted average of the output is 17686. The labor is 635811. The fuel is 4133101. And the capital is 1069119. Now, this is my target input-output bundle. Notice that there is no individual SEB that is producing this output using these inputs. But this output and individual input targets are created by taking weighted average of actually observed output and input bundles from my data set. Now, if I compare this, that is what they should be using or producing with what they are actually using and producing, you see that this benchmark bundle produces just as much output as Rajasthan is doing, is using just as much input of labor, slightly less that Rajasthan is doing, is using exactly the same quantity of capital input that it is doing. But while Rajasthan is using 4806347 units of fuel, this would reduce it to 4133101 units of fuel. And so this fuel use efficiency is what is actual and what is minimally required to produce this output without any increase in labor, without any increase in capital. So this is 0.860. So we will say that the fuel use efficiency for Rajasthan is only 0.860 or 86%. In other words, you can reduce the utilization of fuel in Rajasthan by 14% without increasing the use of labor, without using more of capital, and without reducing output. Now, I have done this for only one of them. What you might want to do is take this model and apply this to each of these observations here, and find out what are the fuel use efficiency of each of these ACBs, and that would be a nice research topic. You not only do that for ACBE, you can do that for any other interstate comparison. And then what you are able to do here is this: you not only just give an efficiency measure, that your fuel use efficiency is only 86%. In other words, you require only 86% of the fuel that you are using compared to I mean, and you can, so 14% of your fuel is wasted. You don't need that much. You not only do that, you tell them that your role models, you see, generally when we say that you have to do better, and if people ask you, okay, sir, I have to do better, two questions: how much better? And how do I do it? And people say, oh, look at others. Who are the others? So here I am specifically saying that to improve its fuel use efficiency, Rajasthan should be looking at the processes and the actual operations of Pondicherry, Tamil Nadu, Andhra, and Punjab. And they don't need to look at anybody else. So now the thing, you have to remember one thing, which is that production is actually performing a series of tasks. Some tasks can be performed sequentially. Some tasks can be performed horizontally, simultaneously. So you have to, so each organization has its own way of organizing work and performing its tasks, its own way of the flow of communications, the own way of scheduling workers and things like that. So if you are really interested in improving your performance, what you should do is that you look at how these four units that I have identified, how is their work organization and management different from what I am doing? And is it possible for me to change my work organization to make it similar to what they are doing? And in this, you can see that for Rajasthan, the more important organizations are Pondicherry, which is given 44% weight, and Andhra, which is given 30% weight, and Tamil Nadu, which is given 24% weight, and only little Punjab. So these are the three, especially Pondicherry, that it should be looking more carefully. Now, remember that inefficiency is a judgment. And what you should, when you are doing DA or performance evaluation, do not use this as a judgment. You try to give them targets, you try to give them role models, so that, you see, they will probably come back and tell you, but how am I going to do it? I am going to, if they ask me, I would say that, look, sir, you are the people who are on the shop floor. You know the technology, you are the technical people, I am not. I am a mathematical analyst and I am just using this data. But what I am doing is I am guiding you to other organizations which within comparable industrial structure who are doing certain things, and you should look at them and you should see what they are doing, which is making them perform in a superior manner, and why you cannot do it. Why you cannot do it? Tell me how you are going to do it. Tell me why you cannot do it like them. Now, there may be genuine restrictions which you cannot do. Say, for example, farming in the Gangetic plain is different from farming in the arid lands of Gujarat or Rajasthan. So you cannot do that. But there are other things which is within your control, and you should be able to do that, because just as in teaching econometrics, we always emphasize that the most important thing about the R square of a linear regression is that it is the least important aspect of the regression. Because if the data are really noisy, there is nothing you can do to improve the R square of the model, because the R square of the model is the explained sum of squares divided by the total sum of squares. So if the data, most of the variation in the data is coming from random noise, there is nothing you can do. So there, your objective is not to throw in your kitchen sink and see whether to getting this in or getting the other variable in is going to improve the explanation of your model. Your objective there is to see what I consider are the relevant variables and is it statistically significant. In economics or similar subjects, people are embarrassed to report regressions with R square equal to 0.45. In anthropology or sociology, if you have got an R square of 0.25, that's considered great. Why? Because in anthropology or sociology, the units of observation are individuals who vary much more in a random way than in economics, where you are looking at this farm and that farm, where there is a consistency between them because they're operating within the same technological framework. So there, in situations where the random variation across units predominate, the important thing is not the R square of the model. The important thing is, are there explanatory variables which are statistically significant? That is what you want to do. Similarly, when you are measuring efficiency, the measured output oriented or input oriented efficiency by itself really doesn't mean much. You have to tell me that you are producing this much output of 1, this much output of 2, using this much of input 1, input 2, and input 3. And instead, you should be able to produce this much more of output 1, this much more of output 2, should be able to use this much less of input 1, this much less of input 2. So this is actually, you are giving them a target. You are looking at the actual and you are giving them a target where the target has got no less, but in most cases, more output than the actual, and the input target is no more, but in most cases, less than the actual input that they are using. That is the use of performance evaluation. Now, unfortunately, I had a much bigger plan, but I feared that perhaps giving you a set of lectures would be less productive than at least covering one topic and giving you a way to use your data and use your Excel solver to evaluate. And then you just remember that doing data envelope analysis, like doing regression, is basically arithmetic. You are taking and manipulating numbers, maybe very sophisticated arithmetic, but still is arithmetic. So for any research, you have to go in the following way. You will ask a question. And when you ask a question, you will have to tell me, why should I be interested in the problem? What is the significance of the question? And then once you have said that I am looking at this question, then the first thing that I'm going to ask, are you the first man in human history to ask this question? In other words, what is already known in the literature about that question? And what exactly are you telling me or going to investigate which is not there? In other words, there is a body of literature, an existing body of research. And always you will have to say that in this paper, we make the following contributions, because the reader, the reviewer, or whoever it is, wants to know what exactly are you going to add, which is new. And then you will tell them that this is the data, or this is the model that I am going to use. This is the data that I am going to use. And then these, you report your results and relate your results. How are you using your results to answer your questions? And economics being a social science, in most cases, people would like to know, is your result or is your research relevant for any policy? Are you going to give me some guidance about how to address a problem? In what way am I wiser after I have read your paper? And another thing that I want to tell you, although this is not about DA, but this is about methodological research. And this is what one of my two gurus whom I consider as my gurus, I never was a student of either of them directly. One of them is William W. Cooper of Churns, Cooper and Rhodes, and the other is William Baumol. And Bill Baumol once said that the main difference between an economics research paper and a detective or a crime novel is that in a crime novel, you wait until the last page to find that it was the butler who was the killer. Compared to that, in an economics research paper, in the very first paragraph, and if not there, not beyond the very first page, there has to be a sentence which says that in this paper, we are going to show that the butler is the killer. Because the objective of an economics research paper is not to keep the reader in suspense. The objective of the research paper is to state very clearly what you are going to find and show how you find it. Also, you should not use unnecessary sentences or unnecessary topics. You do not get involved unless your paper is related to that. Say, for example, I had a student, she was writing about the efficiency in emission control in Indian coal-fired power plants. And the first thing she wrote is, India is a growing economy, and it is foreseen that India is going to have a deficit of power. Who cares? I'm not talking about economic development of India. I am specifically interested, unless you are going to talk about the power requirement, you just cut out that fluff. Don't write anything which is not directly pertaining to your paper, because an economics research paper is not a paper in economic times. It is a very clear professional writing. It's not journalistic writing. And also, and this is a advice I give to all of my students, a machine does not include an unnecessary part. A paragraph should not include an unnecessary sentence. A sentence should not include an unnecessary word. Because, especially these days, the editors are very tight on space. So they do not want you to talk lucidly on this thing and that thing. You have to just give your presentation and get out. And also, in any research paper, you have to tell me what is yours and what you are repeating from the existing literature. When you are writing an exam, you do not have to write that as Euclid has shown. But when you are writing a paper, you have to say very clearly that what is there in the literature and what exactly is the new thing that you are adding to the literature. Now, I've given you a number of hints. I give it to all of my students all the time. And so I think what I will do is that I will draw the line here and will answer any questions. Again, I apologize because the time was short, and given the time, I had some things bungled up, so I lost. But that wouldn't give me enough time to talk about scale efficiency. But those of you who are interested should read my book, the data envelopment analysis book. Anybody who is comfortable with the graduate economics theory book of Varian should be able to read my book. So it's not mathematically very advanced, or rather very demanding, anything beyond Varian's book. That book is, at least. My other papers are probably, but that's where you should be looking at. So I will stop sharing now and answer any questions that you might have.
Any questions from participants sent?
Excuse me?
Any questions from anyone sent, participant sent? No one. Sir, I have a question.
Yeah, go ahead.
Sir, in case of frontier, we can determine the factors which are responsible for controllable efficiency on the part of the fund. In case of DA, can we do the same exercise?
Well, actually, in there are in 1981, I wrote a paper in management science, and that started the so-called second stage regression, where the whole idea is that you have a production function, y as a function of x and a. X are the inputs, a are the attributes. Now, you can think of f of x and a as g of x multiplied by h of a. That essentially means that the x and a are separable. A difference in a will increase or decrease the h of a factor. And for the same x, so long as the x is the same, the g of x is the same. So as h of a increases or decreases, your y increases or decreases, even though your x is the same. So the approach is to do the DA, and once you have got the efficiency scores, which it can be shown under a number of assumptions, is that the DA score is actually your h of a. That is y divided by g of x. Because if you assume that h of a lies between 0 and 1, and if you ignore h of a, then essentially you are doing DA, and the efficiency score is y over g of x. And that is your h of a. And now you can do a regression of h of a, and that really tells you how changes in the attributes, or the what is sometimes called the contextual variables or environmental inputs is going to improve or reduce the performance from the same inputs across the different observations.
Thank you, sir. There are questions. I'm requesting the support team to unmute Dr. Anup Sinha.
Dear participant, you can unmute yourself and ask the question.
Okay. Here Dr. Anup Sinha, then Shweta also ask question, and you please unmute yourself and ask your question. Dr. R. Shanti also ask question and ask a request to please unmute. You please unmute yourself and ask question to sir if you have anything in mind.
First of all, sir, myself Anup Sinha, and it was a really a good informative session. Sir, I just want to ask, sir, you have given the weights to different states for Pondicherry, suppose 40% and so on. So how we can give the weights to the states?
Those are the lambdas.
Okay.
The weights are themselves the lambdas, because the lambdas add up to 1, that is 100%.
Yes, sir.
And none of them is 0.
Okay, okay.
So the weights are the lambdas.
Okay, so that means, sir, depending on the lambda, we
I'm
will
not depending on the lambda. I'm determining the lambda.
Okay, okay. Okay. Sir.
I'm finding the optimal lambda.
Yes,
that
sir.
will give me the maximum improvement in output without requiring an additional input.
Okay, sir. Thank you, sir. Thank
you. Shweta is also requested to ask your question. Please, Shweta, if you are there, please ask your question.
You had a question, Shweta, you had a question about the output efficiency?
Yes, yes.
That's
yes,
what we did in the macro.
Yes.
That by how much we first did the output efficiency. That is how much your megawatt hours are increasing without increasing any input. And then I said that sometimes you want to reduce your input without increasing the output because your input is the priority. As a matter of fact, most of the time, students ask me, sir, is it better to do the output oriented than the input oriented? That's not the question that you should ask me. That's a question that you should ask yourself. Because what are you asking? You are let's say that you are the block development officer in a rural area in one of the states of India. And you are looking into the provision of healthcare, public healthcare in your area. The number of maternity cases, prenatal care and infant care and all that. So you are asking me, is it better to try to reach as many expectant mothers and as many newborn children as possible from the resources that the government has given me? Or is it better to treat the number of mothers and children that I'm paying and try to save on the medicine and the work? That's not for me to answer. That's for you to judge. Whether increasing output is more important or reducing input is more important. However, in some cases, it is not possible to make a very clear distinction as to which one. We don't have a prior kind of importance of one versus the other. And in that case, what you should be doing is that you would be looking at what is the input-oriented technical efficiency and what is the output-oriented technical efficiency. And you should go for one which gives you the lower measure of technical efficiency. In other words, if the input-oriented technical efficiency is lower compared to the output-oriented technical efficiency, remember that for input-oriented technical efficiency, I had the curve and I was moving to the left, reducing input without changing the output. For the output-oriented technical efficiency, the objective is to improve the output without changing the input. And here I am saying that if the vertical move gives you a higher efficiency compared to the horizontal move, then go for the horizontal move where your efficiency is lower. Why? Because the thing is that if you, let's say that your actual input output is X0, Y0. And if you do the output oriented projection, it becomes Y star, which is phi times Y0. And if you do the input oriented projection, it becomes X star, which is theta times X0. Now let us look at the average productivity at the output oriented projection. That is Y star divided by X0. Because you are not changing X0, you are simply moving up. So that is phi times Y0 over X0. And if you do the input oriented projection, the average productivity is Y0 divided by X star, which is 1 over theta star times Y0 over X0, because theta star, X star is theta X0. Now, if the input oriented efficiency is lower, then theta is less than 1 over phi, or phi is less than 1 over theta. That essentially means that the average productivity at the input oriented efficiency is higher. So whichever side gives you the lower technical efficiency, that is the orientation you should take if you do not have any prior consideration as to what is important. Otherwise, it is up to your judgment as to whether you want to, say for example, if you are the fire department and your output is the number of fires that is put out, and your inputs are manpower and car and so on and so forth. There, your objective clearly is to not to start fires and have more fire and put them out. Your objective is clearly to, your fire is given from outside and you want to meet your fire control objectives with the minimum amount of resources. On the other hand, in a country like India or Bangladesh or wherever, where we have got so much of rural deprivation, your objective is not to economize on the resources given to your block. Your objective is to serve as many possible candidates from the resources that you are getting. So whether it is output oriented or input oriented would depend upon your priority. Any other question?
Anyone else? I think, sir, it's over. They have to read some more time and then they will ask you question. But if you are ready, sir, we are ready, particularly me, to listen your body.
Excuse me?
Your body Kavita.
Oh, you haven't given up on that.
No, sir.
Okay, that's kind of awkward because that doesn't that has got nothing to do with DA.
Sir, it has nothing, because you are efficient and you are on frontier, even in case of writing poems.
Okay, so as I asked you, how many people will not understand Bengali?
Is there anyone who do not understand Bengali? Please write in the chat box or unmute yourself and say yes. I think everyone understands Bengali.
Yes, ma'am.
Anyone?
Well,
No.
actually, the poem that Shravanti is talking about is a very small poem that I wrote a few years back, and it was published in the Deshpatrika, which is published from Calcutta. And just to oblige Shravanti, I am going to read this, but it is almost like saying a joke in a funeral or something like that. Well, the poem goes like this. The poem is called Bali, and it goes like this. বাড়িকে প্রতীক্ষারত ফেলে রেখে মানুষ যেখানে খুশি চলে যায়। একদিন অভিমানী বাড়িও মানুষকে ফেলে যেদিকে দু চোখ যায় চলে যাবে। শুধু রয়ে যাবে তার দোরগোড়ায় মুছে আসা বধূবরণের আলপনার ছাপ, আর নিষ্প্রদীপ তুলসী মঞ্চে অব্যক্ত কান্নার মতো থেমে থাকা লক্ষ্মীর পাঁচালির রেশ। Now let me give you an English rendering of this poem called The Home. A man wanders off at will, keeping the home awaiting him. Someday his home will also desert and go away out of her heart pride, wherever the road takes her. Only left behind will be the faded out, auspicious white paint for the new bride at the entry door from a year long gone by, and the resonance of the evening prayers at the unlit pulpit of the resident deity, like the unuttered sobs.
অসাধারণ। I hope when you come to Vidyasagar University, I will get more chance to listen some more poems from you, particularly my favorite one, Maple Gacher Doel Pakhi. I would like to listen it again and again from you. And thank you so much. For you, have a good day, and for us, have a good night and sweet dream. And read DA from my end. Now, for vote of thanks, I request Sneha to do the needful. Sneha, please.
Okay, thank you, folks. I wish I could be more coherent and better organized in making this presentation, but this is such a new thing that it requires a lot of introduction, and just 4 hours is too inadequate for doing this. But I hope that you will get started, and there are people who are doing DA. There are people in South Asia University and in Jadavpur University and other places also who are doing DA, and you might want to, once you start working on DA, if you do, try to create a network, and then the best thing is to exchange ideas and try to learn from each other. Okay then.
Thank you. Sneha, please.
Yes,
Thank you very much.
on behalf of the organizing committee, I feel honored to get the opportunity to propose my vote of thanks. I, Sneha Nath, session coordinator for this session of 2 weeks faculty development program on research methodology and applied econometrics for social sciences. I'm really overwhelmed to convey my hearty thanks to our resource person of this session, Professor S.C. Rai sir, for sparing his valuable time for us to enlighten us with the important aspects of DEA and explaining very lucidly with various examples. It was an outstanding deliberation, sir. My heartfelt thanks to the convener, Dr. Deepjyoti Chaudhary, sir, joint convener, Dr. Shravanti Maiti, ma'am, and Dr. Taraknath Sahu, sir. I take this opportunity to thank all the organizing members of the Department of Business Administration of Assam University and also the members of Vidyasagar University for organizing such an informative program. I would also like to convey my thanks to all the back-end coordinators for their tireless efforts and providing a continuous helping hand for conducting this program smoothly. Last but not least, I extend my sincere thanks to all the participants of the FDP program as well without whom this program would not have been possible to conduct. Thanks to all for making this program a successful one. It was indeed a great learning experience. Thank you.
Okay, thank you and good night.